Welcome to lesson 1.5, least common multiple, or what you sometimes hear referred to as the LCM. Which you see, least common multiple. Okay, in this lesson, you're going to explain the meaning of what multiples are for a number, use lists of multiples to find the least common multiple, and also use prime factors to find the least common multiple. So what are common multiples? Well, the multiples shared by two or more numbers. Multiples are getting larger. That's when you multiply your number by 1, by 2, by 3, by 4. Think skip counting with that number, so to speak. So, yeah, think skip counting. So there's always one number that is the number. One of your multiples is the number itself, and then they keep getting bigger. The least common multiple, the LCM, is the smallest of those common multiples. So greatest common factor was always the same size or smaller than the smallest number. Well, least common multiple is going to be the same size or larger than the largest number. Remember, the LCM has to be basically bigger than the numbers. Could be the same size, but same size or bigger. So it can't be smaller than any of the numbers that are there. So the first one we're going to do is make a list of multiples. That's one way that works. It's okay if you have numbers that maybe have multiples that show up pretty quick. You have to make a really long list. That gets pretty old pretty fast. So what we're going to do, we're going to list out our multiples. So for 4, we're thinking, what's 4 times 1, 4 times 2, 4 times 3, or skip count, count by 4s. 4, 8, 12, 16, 20, 24. Okay, I'm going to stop there for right now because maybe we'll get our common multiple here. If we do, as soon as we find it, we can stop. So let's start. 9 is 9, 18, 27, 36, 45, 54. Have we gotten to it yet? Nope, not yet. Well, 9's gotten bigger, so let's go add on to 4. Let's see what comes next. 28, 32, whoops. 32, 36. Look at that, we got something in common. There's our LCM. Like I said, as soon as you hit it, you got it. You can stop. Then you say, that's my LCM. So that works. All right, let's try it for another pair. 6 and 10. So for 6, okay, 6 times 1 is 6, 6 times 2 is 12, times 3 is 18, times 24, times 4 is 24, times 5 is 30, times 6 is 36. Okay, I'm going to stop. I usually stop after 4, 5, or 6, somewhere in there. Technically, I know exactly where to stop, but I don't want to give that away. Maybe you do too. Okay, count by 10s. 10 times 1 is 10. Times 2 is 20, times 3 is 30. Ooh, I have that in my list. There's my LCM, not GCF, LCM. Don't confuse the two. As soon as you get to it, you can stop. See, I almost stopped at 30. I didn't want to give it away that I knew what the answer was already. All right, so that's using lists to find multiples. Okay. So instead of using lists of multiples this time, we're going to prime factor and see how do we use that to help us. So we've got 16 and 24. We want to find the LCM and prime factor. So 16, 2 and 8. 2 is prime, 8 is 4, and 2, 2 and 2. Okay. 24, 2 and 12, 2 and 6, 2 and 3. List them out. Now, once again, like with GCF, there's kind of two ways we can think about this. Let's see here. 16, 2, 2, 2, 2. 24, 2, 2, 2, 3. With LCM, we want to take the most of the prime factors. So, of all of them. Doesn't matter if they're shared or not. So we see 2s and 3s, which where are our most 2s? Here. So we're going to take all those, and then we're going to take that 3. And we're going to multiply 2, oops, I want to write that underneath. Which you might already know. Okay, that's, I took them all, so that's 16, but 2 times 2 times 2 times 2 times 3, all that equals 48. That's my LCM. Okay, so that's maybe just fine and dandy for you. You prime factor, and you take the most of each prime factor and multiply. Or 16 is 2 to the 4th, 24, 2 to the 3rd times 3. Highest power of any prime factor and multiply. So 2 to the 4th times 3, that's still 48. So highest power of any prime factor and multiply. Either way, 48 we get as the LCM. All right, let's take a different set of numbers, 24 and 90. All right, good news. I already have 24 prime factored. Guess what? I'm not going to do that again. I'm going to use my previously written down work and why I write down my work. So I just got prime factor 90. 9 and 10. 3 and 3. 2 and 5. Okay, so 24 was 2 times 2 times 2 times 3, 90, 2 times 3 times 3 times 5. We want the most of any prime factor. So I'll take those 3 2s, I'll take those 3s and that 5. And I'm going to multiply. 2 times 2 times 2 times 3 times 3 times 5. Whew. That's a lot of numbers, isn't it? Maybe, you can sit there and multiply it all, or you can use the tool like calculator to help you out a little bit. 2 times 2 times 2 times 3 times 3 times 5 is 360. Or if you say, hey, I like that whole writing things as powers, that made some sense. 24 was 2 to the 3rd times 3. 90 is 2 times 3 squared times 5. You take the highest power of any prime factor. So 2 cubed, 3 squared, and 5. 2 cubed times 3 squared times 5 also equals 360. So our least common multiple, either way you find it, is 360. Sometimes you might be asked to find the prime factorization to then find the least common multiple for 3 numbers. So here we've got 3, 8, and 16. I can't prime factor 3. It's only got 3. Okay, so then there you go. You can, when it comes time to listing the prime factors, 3 is it. Okay? 8. Let's list that out. 2 and 4, so 2 and 2. 16, we've done a bunch. So there we go. So 3 is just 3. 8 is 2 times 2 times 2. 16, 2 times 2 times 2 times 2. All right, we want the most of any prime factor, so that's 16, and that's 3. So 2 times 2 times 2 times 2 times 3 is 48, because that's all 16 already. 16 times 3 is 48. Or, if we had written it this way, 3 is just 3. 8 is 2 to the 3rd. 16 is 2 to the 4th. So we take 3 and 2 to the 4th. 2 to the 4th times 3, still 48. Either way you want to find the LCM. So just remember, if you have a prime number, it's already prime factored for you. It is the number. That's all you need to know for that one. Okay, now an example to apply LCM. So one advertising sign changes every 15 seconds, another one changes every 25 seconds. They both just change, so change at the same time. After how many seconds will both signs change at the same time again? Well, we know it's going to be more than 15 or 25 seconds, right? So when are they going to both line up again? Okay, I guess you could kind of start listing it all out. Okay. Or we could prime factor. Either way. So let's kind of do both just so you see how they both work. But what they're asking for here is essentially, what is the LCM of these two numbers? So 15 would be 15, 30, 45, 60, 75, 90, and so on. 25, those 25, 50, 75. Ooh, there it is. I had matching numbers. So after 75 seconds. So if you're feeling good about listing multiples, do it that way. If I'd rather just prime factor, then prime factor. Whoops, not 75. How about 15? That's 3 and 5. Well, that's pretty quick and painless. 25 is 5 and 5. Also, pretty quick and painless. So 15 is 3 times 5, 25, 5 times 5. The most of any prime factors, 3 times 5 times 5, 75 seconds. Or 15 is still 3 times 5, 25 is 5 squared. If you like them written as powers, take the most of any of those, still 75 seconds. So after 75 seconds, both signs will switch at exactly the same time again. So from this lesson, we've learned what multiples are, how to explain them, how to find the least common multiple, listing out all the multiples, and doing prime factorization.